Okay, this is a lecture on elasticities. Okay, in ManQ, this is chapter 5, elasticities and its application. Basically, the purpose of this chapter is the following. Is to introduce the concept of elasticity or measure of responsiveness or sensitivity. Okay. It's basically how what we are going to do is learn how responsive uh, quantity demand is to price changes, quantity supply is to price changes, and other things such as income changes and cross price elasticity, so price of another good. So what do I mean by responsive? What we want to see is when the price of pizza goes up from $2 a slice to $3 a slice, do consumers of pizza drop pizza like crazy, or do they not really change how they eat pizza? Maybe they used to eat 10 slices a day and now they only eat 9. Or do they go from 10 to 1? One is a very responsive change to a price change. The other is not so much. Or when the price goes up, do sellers of pizza respond heavily to price changes or not by much? And the other two we're going to learn is called income elasticity of demand and cross price elasticity. We'll get into that soon. All right. So now, again, what is the motivation? Let me do that with some fancy variables. Okay. Suppose we have an independent variable x and a dependent variable y. So we have a z. Z is some function of x. What we are trying to answer, again, is do small changes in x cause large changes in z, or do large changes in z cause small changes? X cause only small changes in z. So these are the type of questions we are going to study. All right, let's move on. So what is elasticity specifically? It's the measure of sensitivity or responsiveness of a dependent variable to change in the independent variable. And the way we measure it is the following, our measurement of change. Okay. That is equal to, what we're going to do is percent change. Okay. This is here percent, and this is used to denote change. The triangle is, or delta, denotes change. So specifically, elasticity of z, the dependent variable, to changes in x is equal to the responsiveness of z to x, or percent change in z divided by percent change in x. Okay. All right, so let's get into the formula of this. All right, so let me do some erasing. And now we'll... Oh, what just happened? What the heck? All right, you know what? I'm going to just erase everything because I can't select it. Okay. All right. Okay, let me rewrite this. Elasticity of z to x is equal to the percent change of z to the percent change of x. And this is going to be the change, okay? going to be the change of z over z base, whatever the heck that means, divided by change of x divided by x base. Okay? So what is z base and x base? Let's talk about that a little more. All right. So suppose, let's talk about, let's say, an example, change in wages. Suppose you get paid $10 an hour and your boss said, hey man, you're doing a good job. I'm going to give you a raise. Go to $12 an hour. And you're like so happy. You go home and tell your mama, your girlfriend, or whatever, your brother, man, I got a raise from 10 to $12. And he'll ask you, or she'll ask you, oh wow, what's the percent change in that, in your wage rate? And you would say, well, the percent change in my wage rate, that is equal to W2 minus W1 divided by W1. The new wage minus the old wage divided by the old wage. New wage is 12, old wage is 10, divided by 10, the old wage. That's 2 over 10. Ooh, that looks like 20%. I got a 20% raise. Huh? Okay, that's how we would figure it out. Sometimes in economics, we don't know if the wage went that way or if it went the other way. All we're given is you have 2 points. Okay? Wage is 10 or wage is 12. So then if we're given this, some people will calculate it this way, 20% increase. Other people will say, no, man, that's not how it happened. Okay? It went from W2, which is 10, minus W1, 12, divided by W1, 12. So minus 2 over 12, this is minus 1, 6. And that is, if I had a calculator, I could figure this out. Calculator, dig it. Okay, there it is, my calculator. It is 1 divided by 6. Okay. And that would be a minus 16.67% decrease. So it's a decrease in about 17%. And we would argue, you who calculated this and I calculated this, we would argue to the ends of the earth. It's a 20% change. No, it's a negative 16% change. So what we are going to use is this right here, the way we did it here, this is called the point method in calculating percent change. What we are going to use, point method, is the midterm, midpoint method. Okay. And the midpoint method of percent change is percent change of W is equal to W2 minus W1 divided by W2 plus W1 divided by 2. Specifically, the denominator, or what I call W base, is just the average of the two numbers. This is W base, okay? So somebody who thinks wages went up, they would say, well, the percent change in wage is equal to 12 minus 10 divided by 10, which is equal to, 10 plus 12 divided by 2, which is 2 divided by 22 divided by 2, it's just 2 over 11, okay? And others will say, no, wages went down, and it would be 10 minus 12 over 10 plus 12 divided by 2, which is minus 2 over 22 divided by 2, which is minus 2 over 11. So we would get the same actual percent change. It's just we don't know if it went up or down. Now we have just one thing to argue about, whether it went up or down. Okay, percent change, we got an agreement on that. So in this chapter, when we do elasticities, you're always going to do Z base is the average of the two numbers. You're always going to use the midpoint method. You will not use the point method unless the question specifies to do so. All right. All right, so let me erase some of this. Apply the midpoint method to the elasticity formula, and let's see what the elasticity formula looks like. Let me erase, 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 erase. Oh my God, I need a bigger eraser. All right, let's do this. So then this would equal to Z2 minus Z1, that's the percent, that's the change, over Z2 plus Z1 divided by 2 over X2 minus X1 over X2 plus X1 divided by 2. This 2 cancels with this 2, and we could flip this and put it up here, and you get Z2 minus Z1 over Z2 plus Z1 times X2 plus X1 over X2 minus X1. Okay. That is the elasticity formula reduced down. Well, we got rid of the 2's. Okay. The dependent variable, you subtract the 2 numbers on top in the numerator, you add them on the denominator. The independent variable, you add them on the numerator and you subtract them in the denominator. That will always be true. All right. Now, given that we know what the elasticity formula is, we're going to move on. And we're going to do the price elasticity of demand. So we're going to do 4 elasticity formulas here, basically applying that elasticity formula 4 times. The first one is price elasticity of demand. The next one is income elasticity of demand. Third one is cross price elasticity of demand. And the last one is price elasticity of supply, which is basically opposite day of price elasticity of demand. All right, let's finish this. Price elasticity of demand, I'm using PED. How much the quantity demanded of a good or service responds to a change in the unit price of that good. So what does this look like? PED is equal to elasticity of quantity demanded to change in price. And this is equal to percent change in quantity demanded over percent change in price. And this is equal to QD2 minus QD1 over QD2 plus QD1 divided by 2 over P2 minus P1 over P2 plus P1 divided by 2. We cancel these guys. We put this guy up here. And this would equal to QD2. I'm getting more uglier. QD2 minus QD1 over QD2 plus QD1 times P2 plus P1 over P2 minus P1. And that is the reduced formula. Okay. Okay. So let's get some points and do an example. Let's say quantity demanded of pizza, price of pizza, and this is like 100 slices are demanded when the price is $5 each, and the price goes up to $7, only 80 slices are demanded. So if we're given this 4 numbers like that, we could plug it in to find price elasticity of demand. This is equal to the, let's say 100 minus 80 over 100 plus 80. And then I use this for QD2 is 100, so I got to use 5 for P2. So 5 plus 7, 5 minus 7. This is 20 over 180. 5, what is that, 12 over minus 2. 1, 6. 1, ninth. So it's 2/3. Okay, 67%. Okay, 67.7 or whatever, or 67%. All right, 2/3. So how do we use this number? What does PED mean? How do we use this number? Okay, well, remember what PED is. PED is equal to percent change in quantity demanded over percent change in price. So if I plug PED in, 67% is equal to percent change in quantity demanded over percent change in price. Okay. Then I could rewrite this, put this guy up here, 67% times percent change in price is equal to percent change in quantity demanded. Okay, so now this could be kind of useful. How? Well, let's pick a different color. If I know how much price changed by, I could tell you exactly how much quantity demanded changed by. Let's do an easy, simple one. If the percent change in price is equal to 100%, then we know, okay, oh, this is actually a negative number. Here's a negative. Oopsie daisy. Negative, negative, negative. Then we know, plugging it in here, the percent change in quantity demanded is equal to negative 67%, meaning if prices go up by 100%, the amount being purchased goes down by 67%. If prices go up by 10%, the amount being purchased falls by 6.7%. Okay? We could figure things like that out, knowing this number. Okay? All right. So what I'm going to do is clear this. I'm going to keep going. So what we calculated is the following. We said the price elasticity of demand is negative. Okay, and that should make sense. Okay. That should make sense. Price elasticity of demand is less than 0. That should make sense because as price goes up, the amount we buy, quantity demanded, or the amount we buy falls. Okay. However, because of some econ gods out there, we will use the absolute value of price elasticity of demand. Okay. So what we're going to do is drop the negative sign. So when we calculate the price elasticity of demand as negative 67%, we're going to drop that and say it's actually 67%, knowing that when price goes up, quantity demanded falls. All right. If I give you a short answer question and tell you to calculate this, I don't care about you dropping or not dropping the negative sign. But remember that for the multiple choice and true and false sections. Okay. All right. Now, with that being said, price going up, quantity going down, we use the positive number. If someone gives you PED is equal to something like 67%, and they don't explain the data, you don't know if you have a normal, usual good that follows the law of demand, or you have a Giffen good. Because remember, a Giffen good, price goes up, quantity demanded goes up. Price elasticity of demand would be positive. So now you cannot, if someone gives you this number and doesn't give you the data, you might have a Giffen good and you can tell if you have a Giffen good, which means a good that does not follow the law of demand, which is this, or you have a, a normal good that follows the law of demand, this is the law of demand, or a Giffen good that doesn't follow, which is this. All right. Elastic demand. Quantity demand responds substantially to changes in price. Okay. Usually it's PED that's greater than 1. Inelastic demand. Quantity demanded responds only slightly to a change in price. PED is usually less than 1 in these cases. Okay. All right, now we're going to talk about is different determinants of PED, specifically what can cause PED to be calculated differently. Let's do that. All right, availability of close substitutes. Goods with close substitutes, the PED is calculated to be a larger number. You'll be more elastic demand. Why? Because if you're eating, I don't know, let's talk about pho in Westminster. Westminster, there's a billion pho houses. So, and they're all about the same. Yeah, there's some good ones, like super, super good ones, some super, super bad ones, but on average, they're about the same. So if one of these average pho houses decides to increase their price above average, everybody's going to jump ship and go to a different pho house. Not worth it. Okay. We will respond heavily because there's so many other pho houses out there that are just similar to that one. We're likely to jump ship unless you're a hardcore fan of that pho house. Most other people will jump ship and go to a different pho house. Okay. Now, pho houses in the middle of Arkansas or Wisconsin, probably not the same situation because there's not many pho houses in the middle of small town Arkansas. There, because there's no other pho houses there, if the pho place decides to increase the price, customers have to deal with it. They just have to take it. The change in consumption will be not as big. More substitutes, the more responsive you are to price changes. Now, necessities versus luxuries. Necessities, inelastic demand. Luxuries, elastic demand. Necessities, you do not really respond to price changes. Luxuries, you respond heavily to price changes. Water is necessity. I don't know, 20 cents a gallon. I have no idea what water costs. But we need about a gallon to survive. Let's just suppose it's 20 cents a gallon. Let's say the price of water doubles to 40 cents a gallon. All of us, we really need about a gallon of water per day to survive. We're probably going to still drink about the same amount of water, maybe a little less, 0.9 gallon, not the full gallon. But we're not going to respond heavily. We're not going to dramatically decrease our water consumption because why? We need it to survive. We will die. How about luxuries? Luxuries, things that we really don't need. Price falls of a luxury, you might jump out there and get that product real quickly. Price increase for a specific luxury item, like an Hermes bag. Okay, you're gonna maybe move out of that and get a Louis Vuitton bag or something. Okay, you do not really need an Hermes bag, so it's a luxury. So when the price goes up, I'll get something else. Okay. Definition of the market. The more narrowly defined the market, the more you respond to price changes. Okay. The more widely defined the market, the less you respond to price changes. Okay. So let's talk about this, and I'll draw something. Let's define the market. Let's have 3 different definitions of market, going from narrow to super wide. Let's say this is broccoli, and this is green veggies. And the most widely defined is food. When the price of broccoli goes up, your consumption of broccoli will fall by a lot. Okay. Why? Because there's other substitutes that are close enough to broccoli. You got the green trees, and you got the white trees. You got the cauliflowers. Move away. Or you got spinach. You go buy spinach. Okay, some other green thing that's close enough to broccoli. Okay. If the price of green vegetables go up, your consumption of green vegetables will fall, but not as much as broccoli. Okay, P E D, P E D, P E D. Okay, why? Because there's less close substitutes to green vegetables. What can you really substitute for green vegetables? Maybe carrots, orange vegetables. That's pretty much it. Okay. Broccoli, there's a lot more substitutes. Green vegetables, not as much. Price of food goes up. Your consumption of food is probably only going to fall by a tiny bit, if at all. You need food to survive. It's a necessity. Not many close substitutes. So when the price of food goes up, you just deal with it. You eat food and you pay more. So the price elasticity of broccoli is higher than price elasticity of green vegetable. And that one is higher than food. All right, time horizons. Okay, so let's do that one. Okay. Okay, price elasticity demand in the short run is less than price elasticity demand in the long run. You are more flexible in the long run. You will respond more heavily to price changes in the long run. Okay. You have time to plan and react. Okay. That's most likely why. Think about some abrupt change. Let's say the price of gasoline goes up from $6 a gallon to $100 a gallon. Well, in the short run, even if you think that's going to be permanent, what can you do? You need to go to work. You only have a gas guzzling car. Just got to deal with it and pay the. But what are you doing? You're planning right now to sell that car and buy a Tesla or another EV or even a bicycle to use less gas. But until you do that, in the short run, you just kind of deal with it, and you might decrease some consumption of gas, but you still need the car to move around and do your daily business. But in the long run, you get rid of your car, get a EV, and your consumption of gasoline falls dramatically, or your consumption of gasoline responds heavily in the long run, but not so heavily in the short run. All right. Let me clear this. Let's move to the next thing. The demand is elastic if the price elasticity of demand is less than infinity but greater than 1. Demand is considered inelastic if it's less than 1 but greater than 0. Those two I've already explained. Demand is unit elastic if price elasticity of demand is equal to 1. Demand is perfectly inelastic if price elasticity of demand is equal to 0. That means the demand curve is vertical. We'll show that soon. Demand is perfectly inelastic if the price elasticity of demand is equal to infinity and demand curve is horizontal. So let me draw these things for you now. Okay, what does visually this look like? Okay. Here's quantity of pizza, price of pizza. Okay, so we got a vertical line like that. This is price elasticity of demand is equal to 0, or you have a perfectly inelastic demand curve. Okay, this is called perfectly inelastic. Okay, why? This guy who has a demand curve like this says, look, I want to eat 100 slices of pizza. I will not respond to price changes. Price is 50 cents a slice, I buy 100 slices. Price is $3 billion a slice, I still buy 100 slices. I do not respond to price changes. Opposite day of that is a perfectly horizontal line. This is price elasticity of demand is 0. Oh my God, is infinity. And this is called perfectly elastic demand. Okay, the next three I draw is not always true, but for the purposes of this class, we'll assume it is. A horizontal line, we say price elasticity demand is equal to 1. Actually, it's a slope, okay? And we call this unit elastic for the purpose of this class. It's elastic, not the slope, okay? Elasticity. If you have, this is unit elastic, this is perfectly inelastic. So steeply sloped curve, something like this. This is inelastic demand. And then we have opposite of that, which is in this region, unit elastic and perfectly elastic. So if you have a flat line, this is considered elastic demand. Okay, so those are all the visual representations of demand: elastic, inelastic, unit elastic, perfectly inelastic, perfectly elastic. Okay, and again, these three we'll discuss later, not always true. All right, let's clear this. In my notes, I give you real world examples of calculated elasticity, price elasticity of demand. Egg has the lowest at 0.1. Next is healthcare at 0.2. Cigarettes is 0.4. Okay, that means 100% increase in price leads to a 40% decrease in consumption of cigarettes. Okay. The largest one is like restaurant meals at 2.3 and Mountain Dew at 4.4. 100% increase in Mountain Dew price leads to 440% decline in consumption of Mountain Dew. Okay, next we're going to talk about total revenue and how it's impacted by price elasticity of demand. Okay. Remember, total revenue, TR, is price times quantity. Okay. And those things change. PED, price changes. How does demand, quantity demanded change, in response to that? If demand is inelastic, total revenue, okay, if for a price increase, okay, when price goes up, if demand is inelastic, then total revenue increases. Why? Because remember, total revenue is equal to price times quantity. Price goes up, that causes quantity demanded to fall, but it's inelastic. It falls by less than this increase. So that means total revenue goes up. When price goes up and demand is elastic, then total revenue falls. Total revenue is equal to price times quantity again. Price goes up, quantity falls, and it falls by more. It's greater than 1. PED is greater than 1. It falls by more than the increase in price, which causes total revenue to fall. So let me show you this visually, what this looks like. Okay. Here's price of pizza, quantity of pizza, quantity of pizza, will show a very steeply sloped demand curve. Okay, that's a elastic demand. And a flat shaped demand curve. And this is a elastic demand. And originally, maybe we had a price here. Okay. Went too far low. Dang it. So we'll make demand go further, like right there. This is quantity, and this is price. This is quantity right here. Q1, Q1, P1, P1. All right. Remember, total revenue is equal to price times quantity. Price is this vertical distance. Quantity is this horizontal distance. So total revenue is this block for inelastic demand and this block for elastic demand. Now let's see what happens if price goes up. Okay. Price goes up. P2. Q2. P2. Q2. Okay. So here we see now this block is total revenue. This block is total revenue. Here we lost, when the price went up, we lost this, but we gained this. So total revenue increased. Okay. Here, oh, maybe my skills suck at drawing this. We lost all of this. Okay. And we gained this right here. Yeah. Maybe I should have drew it higher. Yeah. Anyways, let me see. This much is about this much. This much. It's about the same, actually. Oh my God, is that much? This much? Is that much? Okay. Well, I guess I suck at drawing. This is not drawn well. Anyways, let me draw a little differently. Let me see if I can draw that again to make it more obvious. Price change. And there. Okay. So then this is more obvious. The other one was not very good. All right. So then here we have like this. This is Q2. And then originally total revenue was this big black box. And now it's this box here. We lost all of this. And we gained only this. And we can see total revenue fell. Good enough. Good enough for me. All right. There's a better picture in the notes if this is all messed up. All right, let's keep moving. All right. So I did say to you that for a linear demand curve, well, I kind of alluded to this. Okay? Let me say it now. For a linear demand curve that has a constant slope, the calculated elasticities can differ at different points. Specifically, we have this. Here's quantity demand of pizza. Price of pizza. Here's a linear demand curve, same slope, right? Constant slope. If you calculate elasticities to some points up there, the price elasticity demand will be greater than 1. And points down here, the price elasticity demand is less than 1. And then somewhere in the middle, the price elasticity demand is equal to 1. Why is that? Well, let's think about this formula. Price elasticity of demand is the percent change in quantity demanded over percent change in price. This is equal to change in quantity demanded over quantity demanded base over change in price over P base. I'm going to flip this guy, put it up there. And this is change in quantity demanded over quantity demanded base. And P base divided by change in price. I'm going to flip these two guys. And this would be change in quantity demanded over change in price times P base divided by Q base. Okay. This here, remember, this is the demand curve. Rise slope is equal to rise over run, and it's equal to change in price over change in quantity. So if you look at this, this is 1 over the slope. Okay. It's 1 divided by slope. And we know no matter where you are on this line, this number stays the same. So this is a constant. This changes. When you're all the way up here and you use numbers up here, okay, these prices must be so high compared to the quantity, okay, that the price elasticity demand is greater than 1. But if you use numbers down here, the prices are super low, the average of the prices, right? And this, the quantity demand is so high that it will flip. The price elasticity demand will be less than 1. And then somewhere in the middle, it'll equal to 1. And so again, it's because the P base divided by quantity demand base. All right. Now let's move on. We are done now with price elasticity of demand. We're going to move to income elasticity of demand now. Okay. Income elasticity and demand, I use IED for that. It's how much quantity demanded of some good or service responds to change in income. So IED is equal to percent change in quantity demanded of some good divided by percent change in M, which I use for income. This is equal to change in quantity demanded over quantity demanded base over change in income divided by M base. Okay. And this is equal to QD2 minus QD1 over QD2 plus QD1 divided by 2 over M2 minus M1 over M2 plus M1 divided by 2. These two cancels, and this flips and goes up there. So then we have QD2 minus QD1 over QD2 plus QD1 times M2 plus M1, M2 minus M1. Again, okay, this is the oh, Jesus, why do I have that? It's the elasticity of quantity demanded to income. Okay, this is the dependent, this is the independent. Dependent always subtracted on top. added on the denominator. Independent, added on top, subtracted in the denominator. Okay. Now, again, just like PD, if I gave you some numbers, we could calculate this. So let's say quantity demanded of pizza, income, and let's say if you make, $10,000 a year, you buy 10 slices of pizza. If you make $25,000 a year, you eat 15 slices of pizza. Okay. So then given this information, let's calculate IED. IED would equal to 15 minus 10, 15 plus 10. 15, I use Q2, so 25,000 plus 10,000 over 25,000 minus 10,000. So this would be 5 over 25. And this is 35,000 over 15,000. Okay. And this we could reduce down. 3, 7, 1, 5. So it'd be 7 over 15, which is, I have an awesome calculator. Hold on. Clear. 7 divided by 15. Okay. And I calculate this number as 0.47, which, okay, 0.47. That's what I have. Okay, so now again, we have IED is equal to 0.47. That is equal to percent change in quantity demanded over percent change in income. So if I know one of these, then I could figure out the other one. For example, if I know income increase by 100%, okay, so we know percent change in income is 100%. Then we know the percent change in quantity demanded of pizza will be 47%. Because you get 100%, you multiply it by 0.47, and you get percent change in quantity demanded of pizza. All right. One thing we can learn from IED is the following. Okay. We have IED. Okay. Is that if it's greater than 0, it's a normal good. Okay. Why? Because remember, income goes up. We learned this in chapter 21 or about consumer theory. The income goes up. We buy more. That's a usual normal good. Income goes, if IED is less than 0, we have inferior good or ghetto goods. Income goes up, quantity demanded falls. We win the lottery. Okay, for normal goods, win the lottery, we buy more Ferraris, we buy more underwear, we buy more white t-shirts. Those are normal goods. We win the lottery, we buy less cup of noodle, we buy less instant mac and cheese. Those are inferior goods. Okay. For normal goods, if IED is large, okay, large positive number, okay, then it's a luxury. Okay. Large positive number equal to large positive number. It's a luxury. For a normal good, if IED is equal to small positive number, then it's a necessity. Okay. And that should make sense. Okay. Necessity like water. I drink about a gallon of water a day. If I win the lottery, I'm not going to drink gallons of swimming pool sized water per day. Okay. So yeah, income goes up. Yeah, I'll maybe drink a little more water, but not that much more. Income goes up. I win the lottery. I'm going to buy a ton of Ferraris. Buy a red one, green one, purple one. All right, let's move on. That's pretty much it for income elasticity of demand, or IED. Now we're going to move to the next one, which is called cross price elasticity of demand. There it is. Cross price elasticity of demand. What is cross price elasticity of demand? This one, the formula might look kind of ugly, but it's basically the same as the other one. Just needs a lot more subscripts. It's how much the quantity demanded of one good or service responds to a change in the price of another good or service. Okay, so the cross price elasticity of demand is equal to the elasticity of quantity demanded of some one good, one, okay, to the price of another good, two. All right. So how does the formula look like? This is equal to QD1, 2 minus QD1, 1 divided by QD1, 2 plus QD1, 1 over 2 all over P2, 2 minus P2, 1 over P2, 2 plus P2, 1 over 2. Okay. Cancel this 2 with this 2 and this, and then we flip this thingamabob and put it up there. And we got QD, oh, Jesus Christ. 1, 2, comma, QD1, 1 over QD1, 2 plus QD1, 1 times P2, 2 minus P2, 1 over P2, 2 plus P2, 1. Okay, that's the formula. All right, so given this formula, let's calculate some stuff. Okay, so we have quantity demanded of Coke, price of Pepsi. When the price of Pepsi is $5 a can, you buy 100 cans of Coke. When the price of Pepsi is $7 a can, you buy 120 cans of Coke. Okay, so let's calculate this. It would be 120 minus 100 over 120 plus 100 over 7 plus 5. Oh no, I did this part wrong. Okay, I'm sure you guys caught that already. Oh no. Okay, when I flipped it, I forgot to flip it. Plus, minus. Remember, it's the independent variable is added on top, subtracted on the bottom. The dependent variable is subtracted on top, added on the bottom. Over 7 minus 5. So then this becomes 20 over 220 times 7 plus 5 is 12 over 2. And this becomes, let's, 1, 11, 1, 6. 6, 11, and I could calculate that with the calculator. 6 divided by 11 is the following. 0.55. Okay? Again, cross price elasticity demand is 0.55. That is equal to percent change in quantity demanded of Coke divided by percent change in price of Pepsi. So if the price of Pepsi, say, went up by, I don't know, 100%, let's do something simple and stupid. That's why I always do 100%. Then quantity demanded of Coke goes up by 55%. Okay. Price of Pepsi went down by 100%. Quantity demanded of Coke goes down by 55%. And I keep plugging other numbers to calculate this. All right. One cool thing about cross-price elasticity of demand is we could figure out if two goods are substitutes or complements. If the cross-price elasticity of demand is greater than 0, like we found for Coke and Pepsi, then two goods are substitutes. If the cross-price elasticity of demand is less than 0, oh, Jesus, I'm so sorry. Okay. Yeah, it's less than 0. In my notes, I have 1. It's actually should be 0. The notes, it says 1. I'll change that, and I'll upload the new notes. Two goods are complements. Okay, it should be 0, not 1, like in the notes. Okay. Okay, let's move on to the next topic. And this is the price elasticity of supply. This is how much the quantity supplied of a good responds to changes in the price of that good. This is opposite day for price elasticity of demand. Okay. So PES, price elasticity of supply, is the elasticity of quantity supplied, how much is being sold, to the price of that good. This is equal to, the formula is percent change in quantity supplied over percent change in price. This is equal to change quantity supply over quantity supply base divided by change in price over price base. This is equal to QS2 minus QS1 over QS2 plus QS1 divided by 2 over P2 minus P1 over P2 plus P1 divided by 2. This 2 cancels with this. You flip that, put it up there. And you get this equal to QS2 minus QS1 over QS2 plus QS1. P2 plus P1 over P2 minus P1. Okay. All right. And again, we could calculate this. Let's do it. Example, quantity supplied of apples, price of apples. Let's say at $3 an apple, they want to sell 100 apples. $4 an apple, they want to sell 220 apples. Okay. And I say, please calculate the price elasticity of supply. Oops. You would say, okay, 220 minus 100 over 220 plus 100. 4 plus 3, 4 minus 3. This is 120 over 320 over 4, 5, 6, 7 over 1. This cancels with that. This cancels 6. What is that? 16? Is that 16? 32 divided by 2. Oh yeah, it is 16. And this is 3/8. So this is 3 times 7 is 21 over 8. And this would equal to 21 divided by 8 is equal to 2.625. So again, the price elasticity of supply, I calculate as 2.625. This is equal to the percent change in quantity supplied over percent change in price. So what we're just basically saying here is if price increases by a certain percent, say 100%, then quantity supplied will go up by 262 or 63%. Price falls by 100%. Quantity supplied will fall by 263%. Price goes up by 10%. Quantity supplied will go up by 26.25%. Okay, that's how you use this number. Okay, clear it. Okay, so what can affect, we went through what can affect price elasticity of demand. We're going to talk about one thing that could affect the price elasticity of supply, and that's time. Time affects price elasticity of supply. Okay. Specifically, in the short run, firms are more inelastic. They're not very responsive to price changes. It's not that they don't want to respond, sometimes they cannot. In the long run, firms are more elastic. Firms are more responsive to price changes. Let's say Camrys. Let's say Toyota, they built out they developed a brand new Camry. They expect, a certain amount of sales. So they base their production based on their projections and their forecasts and all the business analysis. Well, they did something unexpected happen. Let's say their Camry, everybody loves them. And let's say they love it better than the Mazda 6, the Honda Accord, the Hyundai Sonata, the Kia K5, all of the competitors, the BMW whatever, and the Mercedes whatever. People love Camrys, let's say. And they don't buy the other ones. And they're just bidding up the price of Camrys. Even above MSRP, they're just selling like hotcakes. Toyota would love to take advantage of this. But in the short run, their production capacity, only thing they could do is run at about 100%, maybe 110%. That's it. They can't all of a sudden build out a new factory. That's a very expensive decision. Okay? You're talking about hundreds of millions of dollars to build out a new factory, or take the Corolla production down, retool a factory, and build more Camrys in that Corolla plant. That is a very expensive decision. If someone made that decision rashly and spent hundreds of millions of dollars, and this increase in demand, quantity demanded or demand of Camrys was just a fad, and it went away after a couple of months, the guy, the VP of production or whatever, who made that decision to blow a couple $100 million or something to build a new factory, he's gonna get fired. It's a very expensive decision. The short run, they'll run the production plant a little harder and try to meet the demand. Okay, firms would love to sell more, but they cannot. But if they see that this demand for Camrys is just going to be maintained, this crazy hot sales of Camrys is going to maintain, then in the long run, they could decide to build out more factories, hire more workers, and firms in the long run, their response will be more responsive, and they're able to increase production by more. Okay. So remember, price elasticity demand in the short run, firms are more inflexible, more inflexible. In the long run, firms are more flexible. Okay. Next thing. Okay. Elastic supply, same as elastic demand. Price elasticity of supply is greater than 1. Inelastic supply, price elasticity of supply is less than 1. Okay, so now let's talk about price elasticity of supply and what are for the full range of possible numbers. We call supply unit elastic if price elasticity of supply is equal to 1. We say supply is elastic if price elasticity of supply is greater than 1 but less than infinity. We say supply is inelastic if price elasticity of supply is less than 1 and greater than 0. And we say supply is perfectly inelastic if price elasticity of supply is equal to 0, the supply curve is vertical. And we say the supply is perfectly elastic if price elasticity of supply is infinity and its supply curve is going to be horizontal. So now visually, let's provide these thingies. Okay, let's do this. Here's a supply of pizza. Oh, well, that's not how you spell pizza. Here's quantity of pizza, price of pizza. PES is equal to 0. Price elasticity of supply is equal to 0, or we call this perfectly inelastic. You do not respond to price changes. Price could be $1 a slice or $5 billion a slice. You just say, you know what, I'm selling 100 slices. I don't care. Opposite day to that, price is a horizontal line. Price elasticity of supply is infinity. Perfectly elastic. Okay. Now the next three is not always true, just like demand. This is unit elastic. Supply. Okay. Price elasticity supply is equal to 1. If this is unit elastic and the vertical line is perfectly inelastic, so then in this range, we have a steeply sloped line. This is an example of inelastic supply. And then the opposite day to that is a getting a stroke. Is a flat slope line. And that's between unit elastic and perfectly elastic. So this is an example of an elastic supply. Okay. Again, so that's in this flat region. Again, these in here, these three, sometimes not true. Okay, we'll get into that. All right, let's clear this. Let's move on. Just like demand, here's quantity of pizza, price of pizza, and you have a supply curve looking like this. If you use numbers up here, the price elasticity of supply is less than 1. If you use numbers down here, the price elasticity of supply is greater than 1. And somewhere in the middle, the price elasticity of supply is equal to 1. Even though the slope is identical, the calculated price elasticity of supply can differ. And the reason because of that is just the way the formula works, and we'll derive it. Price elasticity of supply is equal to percent change in quantity supplied over percent change in price. And it's because that, P base and Q base thing, okay? This is equal to change in quantity supply over quantity supply base divided by change in price over P base. This is, I flip this, equal to change in quantity supply over quantity supply base, P base divided by change in price. Change these two. Change in quantity supply or change in price. P base divided by quantity supply base. This here, just like demand, this is 1 over the slope. Remember slope of a supply curve, rise over run, change in price divided by change in quantity. This is the flip of that, 1 over slope. So this is constant. For a straight line, this is just fixed, okay? This part here can change. When you're using numbers up here, it can be that the price is so high relative to Q quantity supplied that PES is less than, no, I'm sorry. The price is small relative to quantity supplied. So the denominator gets so big compared to the price, it could be less than 1. That should make sense because price usually, it may not change as fast as quantity supply. Who knows? It can get to that point. Down here, you could have a situation where price is relatively large compared to quantity supplied. It's down in this region, that the price elasticity of supply is greater than 1, okay? It's because of this that we see this phenomena. PES could differ depending on if you're producing in this region or this region. Okay. We are effectively almost done with this chapter. I'm going to do one example, and this is called the following. Does drug interdiction increase or decrease drug-related crime? Okay, there's a couple other examples. I thought this one was kind of, interesting and cute, so we're going to use this one instead, okay? We're going to talk about this one, but you guys should look at the other ones as well. Does going after drug dealers increase or decrease drug-related crimes? So let's suppose, we have a town and they got some money, whatever, from the federal government, and they decide they could do 2 options with this. And I know in real life you could do both, but let's just say 2 options. 1, go after sellers. How? You go after the sellers by hiring more police, getting more drug dogs and machine guns and whatnot. Or you go after buyers. How? You go to the schools, educate the students, hire Kim Kardashian and Tom Brady to walk around, and Brad Pitt to walk around school and say, don't do drugs. And then no one does drugs. Okay? So there's 2 things we could do. And let's study what happens if you go after one versus the other. I'm going to draw this big graph. We have quantity of drugs measured on the x-axis, quantity of drugs. Price of drugs measured on the y-axis, price of drugs. And we're going to have to draw this. Now, demand for drug is pretty inelastic, because it's highly addictive. So even if the price changes a lot, your consumption of drugs stays about the same because, crack is very addictive. So I'm going to draw a very, steeply sloped demand curve. We draw it here too. Supply, we'll just say it's usual 45-degree line, usual shape supply curve, okay? Sellers of drugs could go into all kinds of crime. Don't have to be drug dealers. Okay, supply. Okay, we have this equilibrium right here. This is price star of drugs, quantity star of drugs. And here, let's go after sellers. And here, we're going to show what happens when you go after buyers. Okay, so let's see what happens. Here, we go after the sellers. We make it more expensive to sell drugs. Okay, that means the supply curve shifts upwards. Hire more policemen, more police dogs. Supply shifts back. We get a new equilibrium B. We have P double star, Q double star. You could see here the total revenue for drug dealers is this, and it went to this. Specifically for drug dealers, they lost this sliver, but they gained this massive amount. Okay, when we go after the drug dealers, the total revenue for drug dealers went up. Now let's go after the buyers. Let's go hire Kim Kardashian and tell her to go to schools and say, don't do drugs. The band curve falls. And instead of being in this initial equilibrium here, A, well, P star, Q star, we're in a new equilibrium. Okay. Here, B, P double star, Q double star. Okay. These are stars. Okay. Originally, this is the total revenue for drug dealers. And now it's smaller. You could see total revenue for drug dealers fell when you hire Kim Kardashian. And it fell by this much. Total revenue for drug dealers fell. Okay. And that's because of the way demand curve is inelastic and it's way shaped. So I thought this was kind of interesting and cute little example, simple example of elasticity. We are done with this chapter and this lecture.